Hello and welcome. My name is Sylvia Kemetlian, and I work for the GeneXus support team. Today I'll be telling you about the module object, a new object in GeneXus X Evolution 3. I'll be showing you how to use it and the advantages that this object offers for understanding, maintaining, and integrating a KB. We'll start the presentation on modules by dividing it into 4 topics. First, we'll explain what the module object is and how it's used from GeneXus, both in existing and new knowledge bases. We'll then move on to view the behavior of modules in relation to folders. Afterwards, we'll see what happens when we convert a KB into a new version and the aspects we should bear in mind regarding compatibility. And we'll end with the generators that support this functionality and which generators do not. Let's then start by considering how to work with modules from GeneXus. We'll start with an example of an ERP, like the one in the figure, where a resource is requested. If the resource is available on stock, it's delivered. Otherwise, a purchase order must be made to buy that product or the resource required. To that end, we must then verify the existence of a budget, in which case the purchase is made and later recorded in the accounting. Following the purchase of the resource, it's then delivered as previously. In this case, each of these icons here includes several objects. These objects are usually grouped to better understand the application so that, for example, each developer focuses on a group of objects or on the functionality that's developed. Modules will be of help here in the sense that we may define a module in GeneXus and group those objects in a GeneXus module. Using modules will also imply a benefit for understanding the KB, for its maintenance, and for integrating objects from different modules. Even when a developer joins a work team, it's much easier to show him or her a functionality through objects in a module than modules not sorted or organized within modules. Previously, we did this in GeneXus by using folders, with a specific nomenclature to indicate which objects belong to a specific functionality. But now, there's a much easier way to do that. This is why we say that using modules enables us to better understand the KB, its maintenance, and its integration. So, how do we define a module in GeneXus? By simply clicking the right button on the root module or on any other module we already have. And, as with any other new object, new module. That's how we define a new module. Upon defining it, we are asked about properties such as name, description, and other properties associated with modules. Once the module is defined, the resulting structure is similar to a structure of folders. In the Evolution 3 version, all objects belong to a module. If we don't define our own modules, the root module is always created by default for all KBs in Evolution 3. Modules may also have submodules. In this case, the purchase module has the submodule authorizations. Also, every time that we define an object, we may indicate the module it belongs to. From the module folder option, we indicate to which module that object will belong. And when we do define new modules, we may include objects in them with drag and drop. Which objects may be defined within a module? Domains, images, language, themes, attributes, tables, files, and others. will not belong to any modules because they are global objects of the whole knowledge base. Win objects, just like work panels, menu, and menu bar, may only belong to the root module because Win generators do not support that functionality. The other objects that appear in the column here may belong to any module we define in the KB. So what does a module consist of? Having defined a module, we may open it by clicking the right button, Open, on the module. There we will find three tabs. One is called Interface, another one is Diagram, and the third one is Documentation. The Interface tab is divided into three sections: Services, Data, and User Interface. In the Services section, we define what's known as the module's API. That is, the objects included in this section may be procedure, data provider, and extended object. The Data section includes transactions, business components, and SDTs. The User Interface section includes the master page, web components, and web panels. Every time that an object is included in a module, it's automatically organized into one of these three sections. Let's then see how to determine which objects appear on the Interface tab and which do not. In the figure, we see the purchase model we saw before. The difference here is that when the module is opened in the Interface tab, the purchase transaction is not viewed. However, the customer transaction is. And why is that? It's because the purchase transaction has the object visibility property with value private. This is a new property of objects as from the introduction of modules in the KB. Objects that belong to a module have an object visibility property with possible values public and private. Public means that the object may be used from anywhere in the knowledge base. These objects are the ones that we see in the Interface tab. And private means that it may be used only within the module, including submodules as well. Therefore, a submodule may use the private objects of the parent module. By default, all objects have the public property, and the list of those public objects constitute the module's interface. Private objects are not viewed on the Interface tab, so this object may not be used from any other object in the KB. For example, if we want to make a call of the purchase TRN from an object in the root module, the case will result in a specification error. And that's because the object appears as private and may not be called from another object. So, there is where we must define interfaces to access that object, but we will not be able to make a direct call to that object. That's how we manage which objects are viewed in the Interfaces tab and which are not. The other tab that appears in the module object is the Diagram tab, which enables us to view how a module relates to the rest, which may be referenced or it may be a submodule. The submodule relation appears when a module is part of another module, like in this case, authorization, part of the purchases module, which is a module of purchases. It's there that we show the relation with this dotted line. On the other hand, the reference relation between modules is shown with a full line, indicating in this case that, from the purchase module, the procedure used is located in the stock module. Also, the other thing we may do is double-click to view, in the detail, which objects belong to a module and which belong to the other module. And with the right button clicked on the Diagram tab, we get a contextual menu with more options. These options enable us, for example, to add to other submodules, or add all submodules to see how they relate to one another. Another aspect to bear in mind when working with modules is that we may have objects under the same name with different modules. In this case, we have the product object inside the purchase module and the product object inside the stock module. What we can do to exactly determine the object we're referring to is indicate it with the qualified name property, which is the name of the module dot name of the object. This is how we can have two objects with the same name in different modules. And when we want to reference the objects, we will also have to write them down as name of module dot name of object. Except for the case of objects in the root module, because they do not belong to any module. This is necessary only in the case of an ambiguity, when we have two objects with the same name. And we also will not have to reference the object with the module name in front when the object is one of a kind. We should also take into account that when we use modules in the KB, the URL of the objects in our application is changed, because when we execute an object, from now on we will get the module name prior to the object name for any generator. Specifically, in the case of the Java generator, we have to necessarily use the package name property to indicate the name of the package, and it's also added to the URL generated to reference that object. As we saw before, the purchase transaction has the object visibility property with value private, so we cannot make a direct call to that transaction, though we may make a dynamic call to that transaction. For example, in this case, in the test2 event, we are invoking the purchase transaction as a dynamic call. The only thing we must remember is that when the expand dynamic call property is set with value yes, and this transaction has the object visibility property as private, it will never be accessible for the caller, so it will not be included among the objects liable of being executed. Now let's see the difference between using a module and using a folder in a GeneXus KB. For instance, something we may do is convert a folder into a module by clicking the right button on a folder. And this would be the easy way of turning the folders we were used to into modules. So, as we've seen, both modules and folders help us in organizing objects in a KB. Altogether, they constitute a hierarchical tree where the root module is the root. In the dialog of folder view, we can see the tree formed. Nevertheless, we must say that conceptual differences exist between modules and folders. One of those differences is that modules are part of the qualified name property and folders are not. This aspect enables us to have two objects with the same name in different modules. Additionally, modules may be parents to folders, while folders may not be parents to modules. So, how do we decide when to use a folder and when to use a module? The general rule is that we may use modules to encapsulate and folders to organize the objects within the module. And what we must bear in mind in regards to modules when we convert a KB of versions prior to evolution 3 is that the root module is always created by default. And it's assumed that all objects belong to that root module, except when we define new modules and we move those objects to the new modules. When we have objects with dots in the name, these will be replaced with an underscore in the name property. In regards to the code generated, if we do not define new modules in the KB, the code generated does not change. It'll only make a difference when we start to introduce modules in the KB. And regarding compatibility, after we've opened the KB with Evolution 3, we cannot open it with previous versions because there's no compatibility in that sense. And in the case of using GX Server, we will also need GX Server in Evolution 3. In other words, in Evolution 3, we must use the same version of GeneXus and GX Server. As we saw then, the generators that support this functionality are the Java, Net, and Ruby generators, as well as the generator for smart devices. Win generators do not support this functionality. And now I'd like to invite you to use GeneXus X Evolution 3 and discover the benefits of this new functionality. If you have any questions, you may contact me through my email address, sylvia@genexus.com. Thank you very much.